Good evening, everyone, and welcome to the Q&A session 16 from the playlist of JEE Advanced. The topic is the conditions of projectiles hitting each other when thrown simultaneously from two different locations. So, based on this topic, I have selected one question for this session, which was asked in the JEE Advanced exam in the year 2024. Here, the language of the question is modified, and the content of this question is the same. So the question here is: a ball is thrown from the origin of a playground with the speed of v0 at an angle theta naught with the x-axis. A stone is thrown at the same time from the x-axis of this playground from L, 0. So basically this is the location from on the x-axis from where the stone is thrown. So this is the location on the ground. This is the here the x-axis is the axis on the ground. So the stone is thrown at the same time from the x-axis from L, 0 with a velocity v at an angle theta with the x-axis. So here the stone hits the ball at time t1 when theta, theta naught is equal to 45 degree, and theta, and at time t2 when theta, theta naught is equal to 30 and 60 degree. So we have to find the ratio of t1 upon t2. So in order to save the time, I have already drawn here one figure here. So this is the origin, and this is the projectile motion of the ball, this one, and this is the projectile motion of the stone. So the stone is thrown from at a distance of L from the origin as given in this question, and it is projected at an angle of theta, and this ball is projected at an angle of theta naught. Now here when the a ball and the stone are projected, then at time t1 the ball hits the stone hits the ball, and at that point of time theta is equal to 45 degree and theta naught is equal to 45 degree, and and when the ball is here when theta and theta naught is equal to 60 degree and 30 degree and 60 degree, then the stone again hits the ball. So we have to find the ratio of t1 and t2. So in this question, the most important thing which we have to remember is that the stone will hit the ball only when the vertical component of the velocity are equal, and at the time of hitting the ball, the horizontal distance traveled by the stone and the horizontal distance traveled by the ball should be equal to, that is the sum of the horizontal distance traveled by the ball and the sum of the this horizontal distance traveled by the stone should be equal to L. So here in the first case, when theta is equal to 45 degree and theta naught is equal to 45 degree, so this vertical component will be equal to v naught sin 45, and the horizontal component will be equal to v naught cos 45. So this will be equal to v naught upon root 2, and this will be equal to v naught upon root 2. And in this case also, in the case of the stone, the vertical component will be equal to this will be equal to v. I'm just writing it here. That is v upon root 2. This is the vertical component of the stone, and the horizontal component will be equal to v upon root 2. So in the first case, v naught upon root 2, this should be equal to v upon root 2, or we can simply say that v naught should be equal to v, first thing. Now the horizontal distance traveled by this ball in time t1 will be equal to v naught upon root 2, that is the velocity in the horizontal direction multiplied by the time, and plus the horizontal distance traveled by the stone. This would be equal to v upon root 2 t1, and this should be equal to L. So from here we can So these are the two relations. That is, first one relation is that V naught will be equal to V in the first case. And for the second case, in the second case, the theta is equal to 30 degree. This is equal to 30 degree in the second case, and this is equal to 60 degree. This is 60 and this is 30. So in the second case, the vertical component will be equal to V naught sine 60. So this is equal to root 3 upon 2 V naught. And in this case, the vertical component will be equal to this V sine 30. So this will be equal to V upon 2. So this is in the second case. So in the second case, the vertical component of the ball will be equal to root 3 upon 2 V naught, and the vertical component of the velocity of the stone will be equal to V upon 2. And both these velocity should be equal. So this is equal to V upon 2. So from here, in the second case, I am getting this V is equal to root 3 V naught. Now at the same time here, the horizontal distance traveled by the ball and the stone, that is the sum of the horizontal distance traveled by the ball and the stone, should be equal to L. So the second equation which I will be getting will be root 3 upon 2 V naught. This is the this will be in the horizontal, the component of the velocity of the ball will be equal to V naught cos 60, which is equal to cos 60 is equal to 1 by 2 into T2. So this is the horizontal distance traveled by the ball in time T2, plus this will be equal to the horizontal component will be equal to this V cos 30. So this is equal to root 3 V upon 2 into T2, and this should be equal to L. Now we have to simply solve these two equations by substituting the value of V naught is equal to V in this equation, in the first equation. So if now here we have got two equations, that is, from the first case V was equal to V naught, and in the second case this V was equal to root 3 V naught. So from here, from this one, what I will be doing here is that I will be substituting the value of V as root 3 V naught here, and here also I will be substituting the value of V as V naught. So from first equation I will be getting the value of T1. T1 will be equal to L. This will be equal to V naught, and here also this is V naught by 2. This will also become V naught by 2. So this will be equal to 2 root 2, or we can simply say root 2 can be written in the numerator, root 2, and this will be equal to V naught. So T1 is equal to root 2 L divided by V naught. And now from this equation, if I substitute the value of V is equal to root 3 V naught, then I will be getting T2 equal to, this will become 3 V naught upon 2, and this is V naught by 2. This will become 4 V naught upon 2, and 4 V naught means 2 V naught. So this will be equal to 2 divided by L upon 2 V naught. So these are the two equations which I am getting now, and so T1 upon T2 will be equal to root 2 L divided by 2 V naught, and this divided by T2. So this will be equal to L upon 2 V naught. So this will be equal to 2 V naught upon L. So from here this and this will get cancelled out. So finally the value of T1 upon T2 is equal to root 2. So in the original question they have asked the value of T1 upon T2 whole square. So that will be equal to, if T1 upon T2 will be equal to, T1 upon T2 whole square will be equal to 2. So the ratio of T1 upon T2 is equal to root 2 and T1 upon T2 whole square will be equal to 2. So thank you very much for joining this session. Now in the next session I will be coming up with another type of a question from the chapter of motion in a straight line. So till then have a nice day. Bye.